to remind everybody that we actually have a Odyssey workgroup on generative AI and foundational models. We meet every second Tuesday of the month at noon Eastern time. And of course, we have an Odyssey Teams channel, and everybody is welcome to join. So the first topic I want to talk about is foundational models for EHRs, or FMEHRs, or femurs for short. This is the part where it's not an LLM, but it's used for evidence generation. As you are probably all aware, large language models are what's called pre-trained on a specific task, which is to predict the next word in a set of text. And so you have text that's used as input for the neural network, and out comes the prediction of the next word. And to get really good at that task, what the LLM needs to learn is actually quite profound, because it needs to know about grammar, it needs to know about semantics, and even about context to be able to do this task well. Once the LLM is pre-trained, you can then, of course, use it as just a very expensive auto-completion tool, where you can use it to predict the next word and then the next and the next, which basically is what it means to generate text. But then you can further train such a model to answer, or basically to do specific tasks, such as chatting, and you can use supervised learning or reinforcement learning. And this combination of pre-training with further fine-tuning shows that the model during pre-training actually learned a lot. And there's these papers that show that the LLM actually can pass a doctor's exam with the knowledge that it has learned while basically reading lots of text on the internet. And so what we're working on in Odyssey are these femurs, or foundational models in EHR. They're kind of like large language models, but they're trained on a different task. So it's basically the same technology, but instead of trying to predict the next word in text, we are using it to predict the next, basically, concepts in a patient's record. We pre-train this on all the data in the CDM. So that's one way in which it differs from patient-level prediction, where you usually only have one target cohort and one outcome cohort. Here it's the complete CDM, all patients and all concepts we try to predict. Now, what comes out of this is not a language model. I don't know what to call it, the healthcare model, but I am convinced that these pre-trained models contain deep knowledge. We just have to find a way to actually use it. And so we don't really know yet what exactly the use cases are, but the most obvious one is better prediction models. But maybe also, this is my hope anyway, counterfactual prediction. So if you have a patient, you can choose, well, if I give them treatment A, what will be the prediction for what happens to them? Or if I give them treatment B, what will happen to the patient then? And we can probably use that to guide treatment decisions. Patient clustering, but like I said, we're not yet sure what the full scope of use cases is for such models, but I'm very excited that we'll find lots of useful ones. Again, to reiterate the difference between regular large language models like GPT and these femurs is that language models are natural language models, while these femurs are healthcare models. The LLMs are trained on all text on the internet, while these models are trained on all data in CDM. LLM's pre-training task is to predict the next word, where the pre-training task for these models is to predict the next clinical event. And the fine-tuning task is not chat like an LLM, but for now we're focusing on patient-level prediction, but hopefully we'll have other use cases soon. So we've built a pipeline for this, which looks like this. You have your source data, of course, converted to the common data model. You then download basically your entire CDM database to your local machine, which actually isn't as scary as it sounds. We store it in Parquet files, which are very efficient. And then you have to convert your data into a stream, basically one patient at a time chronologically. And that stream goes into the model. And after training, this model is then your foundational model. Of course, the stream, we'd like to have some sort of a data standard for that, which probably is very similar to the common data model, but of course it's a slightly different restructuring of that. Once you have that foundational model and you want to fine-tune it, say for prediction, now we have to alter this pipeline a little bit, and that we only need to extract data for our cohorts of interest, the target and outcome cohort. We have to go through this pipeline again. And now we take our foundational model as a starting point, and we can fine-tune the model to get a fine-tuned model. And of course, we want to evaluate how well this works, so we have evaluation benchmarks. And so already now in this plot, you have lots of things that we could share. And of course, that's the core of Odyssey, is sharing stuff. So things we could share is the stream data standard. And there's actually already one proposed by the Stanford team. We're already sharing code for converting the CDM to the stream, code for fitting and running models, the foundational models themselves we could share, fine-tuned models, and evaluation benchmarks. Those last three were not yet, I'm not yet sharing them just because I don't have good ones yet, but I'd like to do a shout out to the Stanford, like Nigam Shah's lab that have their earshot, which is a data set plus benchmark and a foundational model that they're sharing on Hugging Face. And so I think that's a good example for the rest of Odyssey to follow. Current status. So we've started this project called Apollo, specifically on this task of training and evaluating these femurs. We've already implemented several pre-training algorithms. You can now fit them on your own data if you wanted to, but you do need big GPUs. AIC has been working diligently on integrating Apollo with the patient level prediction package, so we can run it on the PLP benchmark that Jenna and Ross have developed. And so that's actually the next step to evaluate against the PLP benchmark, and also to build support for the MET standard that the Stanford team has proposed. Now for my second topic, providing tools for AI, which is about LLMs, but just not evidence generation. You probably already noticed that LLMs are more than just chatbots nowadays. You can use them they can actually use tools for you. For example, to find information, like here an example of ChatGPT, or asked it to search PubMed for some articles, and it actually went to PubMed and did that for me. Other tools actually allow you to make changes in the world, such as like book a hotel. And the thing is that actually anybody can make tools and provide them to AI agents. The way that these tools work is, as you usually have a prompt, like I did for asking ChatGPT to search PubMed. Then there is a LLM, not necessarily the same LLM that's used to answer your question at the end. But there is an LLM that's under the hood being tasked with some instructions to figure out if there are any function calls that would be necessary to answer to your prompt, as well as a list of functions that are available to the LLM. That LLM then generates a list of function calls, which can be sent to some API. The output of that are then returned and can be combined with your original prompt and sent to the final LLM to then generate a response that you actually get to see. And so, of course, the question is, well, how do you make sure that you provide the function descriptions to the LLM and then have the APIs to go with that? These API definitions are pretty straightforward. They just use the open API format. So these are recognized by ChatGPT. So you can already create your own GPTs, as they're called, where you can incorporate your own APIs. As you can see, the open API format requires you to document the function purpose, the input parameters, the URL, and the output. So it's pretty straightforward. And so the idea that we've been discussing in the work group is, well, what tools could we as Odyssey provide to AI agents? There are two use cases. One on supporting researchers, and Joe already showed a good example of what that could look like. It's one of the reasons why I like this talk very much. So we could do that at an Odyssey scale. So we can have a tool that provides information on databases in the Odyssey network, just as Joe showed. We can have a tool that provides information about the common data model and its conventions, about concepts in the vocabulary. It could provide information on what concepts are found in a specific database. It could be used to generate concept sets and core definitions. So this is more of actually creating changes in somewhere, and generate study specifications. What I like about this idea of building these tools is that what I don't really like, and I don't mean people do this with the best intentions, but you see a lot of people that do something like ask ChatGPT, write SQL that computes the incidence of diabetes. And sure, you'll get SQL that will run and will give you a number that is supposed to be the incidence of diabetes, but it doesn't follow best practices. It doesn't, for example, use validated phenotype algorithms. And so I think this approach where we have these tools where we can go back and forth with the LLM working against these tools, we can actually have the best of both worlds. So have ChatGPT as your co-pilot, but still follow the best practices as we developed within Odyssey. The second use case that I'm also very much in favor of is to see if we can use create Odyssey tools to support clinical decision makings. So we have already large evidence databases like How Often or the Legend studies have created large evidence repositories that nobody really is using right now. And so we could create APIs where an intelligent agent could use those tools. For example, a doctor might ask, when prescribing X, should I be concerned about side effect Y? And then the bot could come back and say, well, Legend's meta-analysis found a hazard ratio of blah, blah, blah for Y when comparing X to Z. About this many people experience Y while on X. So just to show as an idea that such a bot could actually use the evidence that we've generated in Odyssey. We probably, if you start to think about this use case, we probably need additional results that we would want to generate to fit such a use case. But I also like to point out that this actually fits Patrick's call that he did at the start of the year, that we should be better at disseminating our evidence, not just generating it. And with that, I'm at the end of my slides. Thank you all for listening.